Hello, so let's start today's video, which is the maximum subarray. Basically, I am gonna cover 6 questions of like Kadane algorithm based questions. So this one is the first problem. So this is the maximum subarray problem. So let's start. So what you can think of brute force solution for this question is like we can generate like all the subarrays from this array and basically calculate the sum of each subarrays and like we are gonna take the maximum from all of these subarray sum. So like how we can proceed, like all subarray generation and then calculate minimum subarray and then calculate sum for each of them, and then finally take one which has minimum sum, which has the maximum sum. So this was like brute force. So if you want how to proceed with the implementation, I will show you. Like for brute force, we can simply generate all these strings, and it is generated by using double for loop approach. You have seen it already, like for int I equal to 0, I less than n, I plus plus, where n is the length of the nums array, and for j equal to for int j equal to 0, j less than n, and then j plus plus. Basically, this will not 0, since we are like generating this like sub arrays, like they are consecutive. So initially from like for I equal to 0, j start from 0, then 1, then 2, likewise. So basically, like we can also take here like 3 loops, like that will be as a brute force solution. Let me show you. In sum equal to 0, since for every I to j we are calculating the sum. So like for k equal to int k equal to I and k less than j, k less than equal to j and k plus plus, then sum plus equal to nums of k. We need to have declared sum, which we have already done. We have to also declare n. Int n equal to nums dot size. Now here we have calculated this sum. We also need to take care of maxi variable int maxi, which we are going to initialize with int min. Basically, when we have to calculate max, we basically initialize it to large value, and if we have to use a like mini variable, we basically initialize to max value. So here we have got this up, and then we are basically gonna update the maxi variable, maxi of sum comma maxi. So at last we are gonna return the maxi variable. Let's say it runs fine or not. Maxi, where we are doing maxi comma sum plus equal to nums of k. Here no function is like maxi, we have to take max. So yeah, here it is working, but we can see it is basically of, we can say, overall n cube complexity. So how we can like better approach for this will be like we can remove this k loop. We don't require it, since we can calculate sum on the go, like when j is moving. So like instead of declaring sum here, we can basically declare it here, like we are gonna update the sum with the on-go movement of the j. So like j equal to I, sum plus equal to nums of j, and here we can like update the maxi as we are doing maxi comma sum. Here also it has to run fine. Max equal to max of, oh here colon is there. here you can see the complexity has reduced from n cube to n square. So now we have to like think for some better solution than n square. So what we can think of better than n square is basically n, or we can say logarithmic of n. But here it is not like uh, sorted. So basically what we have to do is like, since it is not sorted, we can think of binary search type approach. So not possible, like logarithmic of n will not be possible. So we will think of like n solution in the direction of big of n solution. So basically what we are gonna do, let me clear this. And like how you can think, like if we have sum initialized to like small variable, small value, then if we like minus 100, this is the main, and when we are gonna add the negative value to it, like minus 2, it basically it basically get worse, like 102, which is more worse. So what we can do, like if any time we are our sorry if any time the value gets below 0, total sum gets below 0, we can simply return as 0. Like if minus 3 plus uh, let's minus 3 plus 1, yes, it's like minus 2. So simply instead of using this minus 2, we can simply update our result as 0. So only positive values gonna get accumulated, so we are gonna get the max value. So like here we have to like do like we have to calculate sum on the go, nums sum plus equal to nums of I. After that what we can do, we can put a check of if sum less than 0, then oh, basically update my sum with 0. So it will, if we are not adding negative value, it will always be like greater. And if we have got the, if sum greater than maxi, we have to like check if sum is greater than maxi, then we have to update our maxi variable with the sum, current sum, like this. So at last return maxi. Here what's nums of I, unidentifier sum. Oh sorry, we need to have declared sum also. And sum equal to 0. Yeah, it's working fine. Let's submit it and check it. Like here we have basically reduced the complexity from big of n of cube n cube to n. So thank you for the solution. And like I am basically gonna post 6 other videos on Kadane's algorithm. So thank